Good morning. Welcome back. So we've been covering chapter 7 on exponentiation. So basically the rules of exponents. We've tackled so many rules in the last week plus. Let's do a baby review. One of the rules that we've covered is the zero rule. When anything is raised to the power of 0, it simplifies to be 1. So it could be a variable to the power of 0, it's 1. It could be a number to the power of 0, it's 1. Literally anything. Notice it's in parentheses. If that whole thing, that whole parenthesis is being raised to the power of 0, it is 1. That's one of the rules that we've learned, the zero rule. Another rule that we learned is the product rule. That's this top one here. So when we have like bases, the base is the 3, and we're multiplying, we add our powers. So 3 plus 5 is 8. So when we have like bases and we're multiplying, we keep the base and we add our powers. Another rule that we tackled was the power rule. When you have a base and it's raised to a power to an additional power, so now we have two powers right next to each other, we multiply those two powers. And in this case, we kept the base of 3 and we multiplied 5 times 3 to get 15. Another rule that we've covered is the negative exponent rule. So we realize that a negative exponent is an unhappy exponent. And you can imagine that there's a vinculum here, a fraction bar line, and a 1 underneath. This 3 is an unhappy 3. We can tell because its exponent is negative. How do we make it a happy one? We move it. So if it currently lives upstairs, the only place it could move is downstairs. And then the power becomes a positive. Technically what we just did is we took the reciprocal. That means we flipped it downstairs. And then we changed the power to a positive. They went a little bit further on this poster and multiplied it out because 3 times 3 times 3 times 3 times 3 is 243. And then we have these two rules. We have the power over a product rule. So when you have a product, remember that's just a fancy word for multiply. So A and B are being multiplied here. So it's like two kids inside of a classroom. Think of the parentheses as the classroom walls. And the teacher is going to distribute or share the 3 with both people in the class. So that's Albert and Bert. So, wow, real creative there, Miller. And then you're going to share the 3 with both of them. And it would be Albert with a 3 and Bert with a 3. You could also use it this way when there's a number and a letter. You would share the 2 with both as a power, rewrite it, and then I expand it a little bit further because I know that 3 squared is 9. Another rule that we are tackling is a power over a quotient. Same thing as that last one, except now we have an apartment complex. We have Albert living upstairs, Bert living downstairs, and we're going to share the 3 with both. And that also works when we have a number and a variable. Okay, so we have that rule as well. And then the last rule that we need to learn, and that's today, is our quotient rule. I will be honest, it's one of my least favorite rules. And it is a rule that many kids struggle with. My second language learners, my at-risk learners, kiddos with attentional issues, kiddos with processing deficits, kiddos who struggle with dyslexia, dysgraphia, dyscalculia, kiddos who struggle with subtraction of integers, aka positive and negative numbers. It is just one of those rules that just most kids struggle with. And you know who else who struggled with it? This lady. And I have a degree in math and I struggle with that rule. So it is imperative that we practice, right? But I'm not going to teach that rule directly as it is. If you want to see that rule taught directly as it is, Khan Academy. Type in quotient rule for exponents and you will be taught directly with this rule. It's just not the way I see it. So I'm going to veer off into my own Miller direction and teach it to you the way I see it, okay? So if you haven't been on Canvas yet, I would suggest you do, go to your module, go to 7.4, and I have 2 worksheets there. The in-class 7.4, which is what my videos will cover, and the homework 7.4. So please print both of those, and then let's get started, okay? So, let me get all of this jazz out of the way. Nice. So, we're gonna go with the 7.4 rules of exponentiation in class notes. So that's what I want you to be checking out. Now, the in-class notes are 1 through 16, and I'm gonna boldly start at 5. We will go backwards, but I'm gonna start off at 5, okay? Because I think if I start off at 5, there's a better chance that you all are going to get it. So, surprisingly, okay? So, me starting at the middle of the worksheet is better. So, I just moved the camera a little bit closer. Perfect. So, we're gonna start off at 5. Now, I'm not using the quotient rule the way that it's intended. I see this a little bit different. Okay, so here we go. First thing I do when I see a quotient, aka a big division question, is I write an equal sign and a fraction bar line so that I can see it best. I see that there's 3 types of things involved in this question. I see there's a regular number, I see x's and I see y's, and we're going to tackle them individually. So the first thing is, let's take a look at the number. I see a 2. Do you see any other numbers? Nope. So 2, there's no one to multiply it by or divide it by or reduce it. So he just stays. He's clearly a happy 2, so he's going to stay in the upstairs position. Now I'm going to look at the x's. Oh, I see some on the top and the bottom. I'm going to ask you 3 questions. Are there more x's on the top? Are there more x's on the bottom? Or are they the same amount of x's? If you said same amount, beautiful. If you have the same amount of variables on the top and the bottom, like I have 2 x's on the top and 2 x's on the bottom, they cancel. They eliminate each other. And if you're like, but why? Well, there were 2 x's on the top and there were 2 x's on the bottom. One of the rules of math is we can cancel anything that we see on the top and the bottom. So they would cancel completely. Now let's look at our y's. It's our last thing to look at. Do you have more y's on the top? Do you have more y's on the bottom? Or you have the same amount of y's? Which one? Nice. If you said there are more y's on the bottom, I agree with you. But now I have a follow-up question. If there are more y's on the bottom, by how many more are on the bottom? So you had 2 y's on the top and you had 3 downstairs. You had 2 y's on the top and 3 downstairs. You already told me there are more downstairs, but by how many extra? There is a single extra y. And my friends, that is our answer. Now, if you want to see it more visually, you had 2 y's on the top, you had 3 y's on the bottom. So when in doubt, write it out. Help your brain to figure it out, right? If our brains need to see it because we're super visual, then you don't hesitate. Just write that out so you can see that. Okay, I see the 2 y's now. I literally see it with my eyeballs. And I see the 3 y's downstairs. We know that there's canceling, 1-to-1 canceling. For every 1 on the top, you can cancel 1 downstairs. And then there you can see there's literally 1 y left over on the bottom. Perfect. You got it? Let's look at 7 since we're right here. We're standing right next to it. Okay, so I see a number on the top and the bottom, and they're the exact same. So 3 divided by 3, they cancel one another. And we get an invisible one. Okay? Where do you have more y's? Now be careful, they didn't put them exactly on top of one another. I have a single y here and I have 3 y's here. Do I have more y's on the top, more y's on the bottom, or are they the same amount of y's? If you said more y's on the bottom, I agree. By how many? 2? Yes. And again, if when in doubt, you need to write it out, cancel to help your brain to figure it out, you do that. And let's look at our x's. Where do we have more x's, top or bottom? Or are they the same? Bottom. By how many extra are downstairs? A single x. Now, if you want to swap the position and have the x first and the y squared second, that is acceptable as well. We can't leave that as our answer because those characters are on the bottom of the fraction. They're in the denominator position. I need something that holds the numerator. What is it? 1. Nice. Perfect. let's go over here and look at 6 and 8. So I'm going to erase this and I'm going to scooch this worksheet over a little bit so we can see it best. So now we're going to look at 6 and 8. And again, I on purpose skipped 1 through 4, so you didn't like miss a video or anything. Let's look at this guy. I don't see any numbers, so the first thing I do is, okay, cool. I see a single X on the top. I see 3 X's downstairs. Where do you have more X's, top or bottom? If you said bottom, I agree. By how many extra do you have downstairs? Yes, there are 2. Where do you have more Y's, top or bottom? If you said bottom, I agree. By how many extra? 2. We're done. And our 1 space holder will hold the top. Now, if you're like, what the heckers? How'd you do that? You are a when in doubt, write it out. Help your brain to figure it out kind of a kid. And there is nothing wrong with being that kind of a kid. You are wired beautifully and perfectly. You're just really super visual. So let's see. I have an X and a Y on the top. Oh, shenanigans. Sorry about that. And then I have 3 X's. And then I have 3 Y's. Just make sure your writing's, pretty legible. I see that X can cancel with him. That Y can cancel with him. I literally see with my eyeballs the 2 X's downstairs. And I see the 2 Y's downstairs. And then I have that 1 space holder. If you need to do it that way, then you go, little rock star. You do your thing, okay? So I'm going to stop the video here, and we're going to start part 2 of the 7-4 video. Have a great day. Bye.